welcome back to the show. Today my guest is Kurt Hollowell, and I met Kurt when I was living down in Miami. He is a board sport enthusiast and video game designer. So Kurt, thanks for being on the show.
Yeah, thanks for having me, JT. It'll be fun.
Cool. Yeah, maybe we can start off talking about, and I've always kind of been jealous of your career and being able to make games and do cool things with technology for a living. So maybe you can talk about that journey when you first got interested and how that path unfolded for you.
Sure. Yeah, it started um, at the university tour, touring the campus and going through the engineering lab. I didn't really know what I wanted to do. I think like most people going into university, right? Like you kind of just need a list of degrees and you're like, that one seems interesting or whatever, right? So we were doing this tour and program where you can learn to make video games. And that kind of hit me like a bolt of lightning. Like, what? That's a job? You can do that? That sounds amazing. Yeah, hell yes, I want to do that. So I talked to that professor who was running that program, and he told me to get a computer engineering degree. So I did, and I went to the University of New Mexico. So I'm from Albuquerque, New Mexico, and unfortunately, you couldn't take that class to make video games until your senior year. You needed like
Oh
all these
yeah.
prereqs and all this stuff. So my whole university career, I'm just getting ready and excited to take this class. And then turns out by the time I was ready to take that class, entering my senior year, that professor moved to a different university and the program wasn't really there anymore. And so at that point, I just decided to kind of take it into my own hands. And thankfully, I had some other people who encouraged me to do some senior projects and stuff. I was able to get credits for making video games, and at that time, I was just going to school and working. I had a day job at Sandia National Labs, which was great programming job, but not super, it's obviously not video games or whatever, programming 2D applications and stuff. So basically at home, I was always just making games on the side. And thankfully, I got plugged into this Albuquerque Game Developers Guild group, which was really cool. I found this community of game developers that met every week. They still meet every week if anyone who's listening is interested in that. And that was really cool because every week people would show off what games they're working on. And there's artists and there's musicians and there's programmers, and you got to show off your stuff. And that got me really excited about games. And then at my job at Sandia, we started seeing some emerging tech come out. One of my office mates and I got really excited when HoloLens came out, which was the world's first holographic headset, like augmented reality thing from Microsoft. This pretty big visor with this helmet thing, right? And then you get this tiny little screen, right? But it was pretty cool. Like it could put holograms in the world. And so then our minds just started going, you know, imagining the future that's covered in holograms and this like blending of the digital and physical world. And so then I think, yeah, my interest transitioned a little away from games and really into emerging tech and these like AR and VR glasses. And yeah, now for the past 7 years or so, I've been working at Magic Leap, which makes these headsets.
Very cool. Yeah, and I know the intersection of reality, virtual reality, augmented reality, there's a lot of different things to consider. And as we were touching up about you coming on the show, you wanted to explore topics of life and consciousness, that lens of looking through it, especially because you're so deeply involved on a technical level of building these other worlds inside of a digital space. I'm sure that a lot of your thought processes go around, okay, if I'm designing this world, then how did this world that we actually live in get designed with? So maybe we could use that as a little starting point for your own thoughts, theories, philosophies around story of the universe and all the way back to the very beginning up until now, wherever you want to launch off from that one at. But
For
curious,
sure.
curious your thoughts on that.
Yeah, I think in university as well, I kind of started going through, I don't know if you call it like an identity crisis or something, but just looking at the universe and I think everyone has this moment in their life where they're like, WTF, basically, where did this all come from? This universe is huge and we're all alive and this is weird, you know what I mean? And like just trying to understand it all. And so I started at that point diving really deep into podcasts like Lex Friedman and Joe Rogan had a lot of cool scientists on that talk about everything from astrophysics and the size of the galaxy and the formation of life and consciousness and all these topics. So yeah, today I was hoping we could talk a little bit about information theory, which at a high level is viewing the universe through the lens of just information, and then abiogenesis, which is a study of how non-living things became living, like kind of the origins of life.
Yeah, yeah, it's pretty big topic. So let's see if we can
Yeah.
maybe narrow it down a little. So that term abiogenesis, I think when you were discussing it, wanting to bring it up on the show, that was the first time I encountered that word. You just described that it's when something non-living became living. And in your research and your explorations, where was that line, I guess, created? Where is it crossed? What's your view on that?
As far as I can tell, the universe has all these laws of nature, right? It's like chaotic soup, the universe, whatever, since the Big Bang, there's all this stuff out there and it starts interacting with each other. You have, these quantum mechanics, obviously, and then atoms, and these atoms start getting attracted or repelled from each other, and some of them clump together and form molecules, and those different molecules have different properties just through the nature of their structure, and then molecules all come together and we start getting like structures and materials and things like that. And so things kind of tend to just have these emergent properties based on their structure and the laws of nature, where some things get attracted to each other, and just because they have a certain shape or certain electromagnetic properties or whatever, this we live in this universe full of this chaotic soup of stuff, and that stuff has all these interesting properties, right? And the way I like an interesting story for abiogenesis is that as soon as you have these molecules that started to get more and more complex, eventually, just through the sheer physics nature of reality and physics, the first replicator was born. So you could imagine a box full of a bunch of random stuff in it, and all the stuff is kind of bumping into each other. And as it bumps into each other, weird things are happening. And for billions and billions of years, eventually, just through the nature of this thing, started with its shape, it started replicating itself. Like it has material in the environment that starts collecting together, and then this thing makes a copy of itself. And so you could kind of think of that as, I think a replicator is an interesting word because it describes what you're talking about here. Like this thing just starts making copies of itself just through, almost by chance. It starts attracting things, they come together, and then replicating. And then as soon as you have this replicator, these things start holding information, and you can think of information in different ways. Like right now, we think of like DNA or whatever, right, as holding information, and the precursor. I mean, I'm not a biologist or a chemist, so I might say some wrong things here. You know what I mean? But I know DNA is made up of proteins, right? And protein chains are these really complex things. But you can think of them as like Lego bricks or something like that, But you can imagine this kind of like entity that starts making copies of itself, and those things hold information. And as this thing's making copies of itself, sometimes there's mistakes when it's not making a perfect copy of itself all the time. Not all the copies are unique. And as soon as you have this environment, you have natural selection as a force of nature, which I think a lot of people know about, of course, Darwinian evolution, and you think about natural selection, but I think most people don't think of it as a force of nature, like something that just exists inherently from these systems in the universe. And so, yeah, as far as I can tell, the first replicator was born somewhere. It starts making all these copies of itself, and then the natural environment selects for whatever does the best job of that, making copies of itself. Each of the copies start making copies, but they're all a little bit different. But the environment selects for, the environment has selective pressures,
Right.
which,
Is there like a
yeah,
parallel as you're describing that, like this kind of replicator process and survival of the most fit for that environment comes even before there's any sort of conscious animals running around that are competing in an ecosystem, maybe the molecules themselves on whether the bonds electromagnetically were correctly arranged and the ones that aren't are just deteriorating and falling into nothingness. Is there like a similar process happening when you're designing systems in software and computer simulated reality? Is there like that how hardware operates? Do you have any sort of parallels on that replicator or how
Hmm.
molecules are kind of coming together on their own when you're building these virtual worlds?
There is like a long history of computer scientists who have tried to create a digital world or create, and a famous one is called The Game of Life. And this one computer scientist, I think, wrote some code. It's just a mathematical equation. Like he set up a 2D grid, basically just a pixel grid, and then had just a mathematical formula for like, okay, you randomize, like initialize some values on the grid, and then you have some kind of formula for like how things change over time. The game starts with just like input user, like they click on a pixel or something. They click on a pixel, and then there's something happens to all the pixels surrounding that one. And so if you look up videos of the game of life, it's pretty interesting. I think just with the right math, you start seeing these all this weird stuff happen to the grid, like these like waves start going across, and then these little entities, these things, these little pixels get formed, and then they start crawling around in the environment just through pure mathematics, and they start evolving and changing. And there's this weird thing with the game of life that you can't predict the outcome. You can't predict what's going to happen. It's kind of this weird simulation of life in a box or something like that. I mean, that's maybe the
Just because like
closest thing.
like the probability you said you can't predict it. You'd imagine if someone designed this game and it's all based in math, one would expect that you could calculate out all the different possibilities for the outcome. But you're saying they're just so close to infinite that it's impossible to know what happens based on where someone clicks on the screen.
Yeah, right. I think that's a good way to put it. And yeah, it's been a long time since I looked at that, but yeah, it's pretty interesting to check out the game of life. And maybe another thing that comes to mind are like procedural systems. So these days, when you're designing a game or an experience, there's a couple ways to do it. You can basically handcraft everything to the finest detail, or you can create like generative systems that are like sort of random, which have maybe unique properties that like no one can really guess. So like a lot of like space games will do that. Like maybe a more recent like famous one is called No Man's Sky. They started creating this universe simulation, and there's a lot of people who do procedural planet generation and star formation, and they start inputting all these rules based on the universe, the natural laws of the universe, of gravity and star formation, or whatever. I mean, a lot of scientists do that stuff too, to run simulations to understand how the universe works at a large scale, like the galaxy. We input all these rules and parameters, right, and then run the simulation and kind of see what happens.
Mm-hmm.
So there is a lot of different ways I think computer scientists are creating these digital universes or worlds.
Right. And I can't help but to bring up the, I don't know if it's conspiratorial or whatever, theory that this universe that we're living in now may be a simulation created by some previous entity. Maybe we're inside of some sort of machine or computer or whatnot, some sort of version of a system and software running on top of it. Do you have any thoughts on that as your own work itself as creating these digital universes and worlds, and like how you perceive your real tangible day to day life? Has that crossed your mind thinking about that theory?
I think it's an interesting thought experiment. And basically, as I understand it, the premise goes like this, that like we're looking at our computers and how the technology is going up on this exponential curve, like the ability of our ability to like simulate worlds in video games and stuff. I think everybody can see back from like, basically Pong or whatever, like a couple pixels, now to being in like these VR, immersive, super real, hyper realistic environments and et cetera. And especially with quantum computing, quantum computing is where it starts to get really weird because with like computer systems, they are improving on an exponential scale, our computational ability or whatever. But I think the quantum computers are like hyper exponential or something like that. In a normal computer, you have bits like ones and zeros, which is basically at a low level, just like, okay, there's charge in this spot or it isn't, right? Which represents a one or zero. Then you get long strings of those numbers 0, 0, 0, 1, 0, whatever, and those represent higher forms of information like the letter A or the letter B. Anyways, with quantum computers, you just add one more qubit, and um, there's something that with just a small number of qubits, you're able to simulate like every particle in the known universe or something like that. Like the computational power just gets kind of mind-boggling pretty quickly. And we're already starting with these quantum computers to get more and more qubits. Like every year, the number of qubits is like doubling. So the computational power is kind of just unimaginable. So the premise for simulation theory is that, okay, we can see in our near future the ability to simulate entire universes, on a computer. And if that's the case, then we'd be able to run a trillion universe simulations or something like that. We have these basically infinitely powerful computers that can simulate universes. If this does exist, the ability to like simulate universes in a computer, then what's the probability that we're in like the base universe versus one of these simulations? Like, well, the probability is like 1 in 10 trillion or whatever that we're actually in the real universe.
Like the original one, right?
Yeah, the
Yeah, because
original one.
you wonder if someone creates like a simulated universe and it has like these little beings on there. Do those beings think that they are sentient and like are they exploring their universe like we are? Like what level of consciousness do they have? I think that's an interesting point that different shows, and that show Black Mirror I think did an episode on it too, where it's like, oh, we're these souls that we think we're real, but we're actually in a simulation. And if you blow up this computer, then all these other parallel universes of souls that think they are real are going to be destroyed. All these
Yeah.
different layers and different dimensions that exist. Talking about quantum computers a little bit more specifically, these were theoretical, I think, right, for a long time, and now they're very much real and actually computing things. Have you interacted with them in any way or seen like projects coming out of using quantum computers?
Yes, I haven't really interacted with them other than just watching podcasts and stuff like that. I think 5 years ago or something, it's what we imagine the first normal computers to be like, where it's like a whole room dedicated to this. Like for quantum computers to work, you have to get two entangled particles. And to entangle particles, you need super freezing, like zero temperatures. And I remember seeing some of the first quantum computers. It's like literally a whole room with this crazy coolant and all this. But I think recently Google has been making a lot of progress that I've seen, and I think NVIDIA and all. And now there's like a little chip, I don't know, 24 qubit or something crazy, which it used to be like 2 qubits, or you know what I mean? Versus,
Right.
okay, we have like two entangled particles and we have this quantum computer and it's this whole machine. And so that's already shrinking to be more of what you would might look like what might look like a normal computer.
Yeah.
I think effectively the way they work is with a normal computer, you input a string of zeros and ones and perform math calculations on that, and then you get like an output of zeros and ones. And so it's like serial. It's like information comes in, you do math, it comes out, comes in. And so that's like the processing rate of your computer. You see that your processor speed is like whatever, 3.7 gigahertz or whatever. Like that's like how quickly you can just take in the information, do some math, like get something out.
Hmm.
But with quantum computers, it can like do multiple calculations at the same time. So it's not just like one at a time. Like you can do like 30 calculations at the same time because you're like leveraging the fact that these quantum bits like exist in a bunch of different states at the same time. So you're like doing math in other dimensions almost or something like that.
Right.
Like you have like this multi-dimensional computer, and like every frame, one set of zeros and ones come in, and then you do math and this infinite number of dimensions or whatever, and then get a bunch of results at the other side. Probably not saying that perfectly, but it's something like that.
Yeah, and I
Right.
mean, and that in and of itself, up until quantum computers came out, quantum mechanics and string theory were just theories, and there was no way to prove that these other dimensions existed. But seemingly, with these machines that are leveraging quantum mechanics, and you're saying these calculations are happening faster than any traditional computer could, it seems like it's almost just straight evidence that, like, yes, there are multiple other dimensions because they have to be, because otherwise how are they doing these calculations so quickly? Does that seem like a fair
Yeah.
assessment? It's almost like proof just by the output.
I don't know if it's proof. I think the scientists are looking at quantum mechanics and seeing how weird it is and then coming up with stories. You know what I mean? Like we're trying to kind of understand it. And yeah, I think the multiverse thing has obviously been in pop culture like a lot these past 5 years, right? And my understanding of quantum mechanics is that at the smallest level, an atom actually exists as this probabilistic wave function. So there's this energy wave that has a probability to, when you measure it, to like collapse into a certain particle or something, right?
Right.
So it's like, okay, here's this weird nebulous thing that's in an infinite number of states, but then when you look at it, you view a result. What we can tell is that there's a probability that when you look at it, it'll collapse into a certain thing or so.
Hmm.
That's as far as I know the science behind it, and then you can kind of like make up whatever story you want to understand that. One of those is like, oh yeah, the universe exists in an infinite number of states. The universe is at its base level a probabilistic wave function that exists in an infinite number of states, and somehow we like experience some slice of it. I mean, I
Right.
don't know. Yeah, it's
Yeah,
weird.
it
Yeah.
makes my head spin. I think like one of the maybe easier to comprehend, or maybe just slightly more straightforward examples of quantum computing is, I was explained, there's a traveling salesman problem, right? And like this guy is starting in New York and he needs to hit like 50 different cities across the United States, and he can devise his own route to get to these cities. Some take longer than others, depending on which order he does the whole trip in. And if you feed this problem to a traditional computer, because of all the different options and all the permutations of it, the order of the cities 1, 2, 3 through 50, it would take a normal computer maybe like 1,000 years to calculate all the results of all the different paths this guy could possibly
Uh-huh.
take. But if you give it to a quantum computer, it can do it in like a minute or something. It's like that
Yeah, it's
that
because it does all the
exponentially.
That's
Go
because it
ahead.
does all the calculations at the same time,
Right.
like it's,
That's
yeah,
like, well then, yeah, and then it's like, well, how does it do that? And then
yeah.
like you're saying, like maybe it's going off into another dimension, calculating over there and using the time over there, and then bringing it back over here before that minute ran out. It seemingly makes zero sense whatsoever, yet it's like very real and happening. And obviously, these companies are building these machines, spending billions of dollars on them, and they're having like breakthroughs and technological advances that we've never seen before. It's almost like a little bit scary what happens next, as far as like if these things really are that powerful. Like what
Uh-huh.
kind of use cases, I would say, there's probably good and bad. Like, do you have any thoughts on like really good use cases for these things, and maybe some things to look out for?
Uh-huh. Well, I know like encryption and decryption are going to be impacted a lot by quantum computers, which for the non-computer scientist person, encryption is, when you log into a website and you type in your password or whatever, they have to verify that you're typing in the right password, but they don't want to store your actual password in their database because then they have your information. And if that gets leaked or whatever, like if someone gets access to their database and they can look and be like, oh, that's JT's password, like let me, you know what I mean? So there's this security behind that, and what they do is what we all did as a kid, as friends with your friends on the playground. I used to do this where you write A B C D E, you write the alphabet, and then next to it you write like code. It could be symbols, it could just be the alphabet but in a different order or something, and then that way you kind of have a key and an expected output, and you can write something down in this encoded language or whatever, right? And so
Hmm.
that's how a lot of computer security works, is through encryption and decryption, but they could use like math formulas. You could imagine, when I see, let's take every letter in the alphabet, give it a numerical value, and then do some complicated math to it, and then it spits out this kind of thing at the end. And why that's secure is if you get the thing at the end, it's very hard to guess like, oh, what's all the random math that someone did to figure out what the original input string is or whatever. So that's another problem where a traditional computer would basically have to guess and try everything
Hmm.
until it can figure it out. But with quantum computers, it can solve that problem very quickly. So that's concern, is that like the entire internet is based, and all of our day-to-day interactions, like our bank account information, all of our personal information is stored in a million places, and it's all encrypted to try and keep us safe, but that's kind of all about to break. But I guess the good news is you can also use quantum computers for encryption, and if quantum computers are really expensive, maybe that's the barrier, like blockchain technology as well. Like I think that's maybe the one thing that could potentially be the demise of Bitcoin is quantum computers, because they can hack the keys. Blockchain is, I don't want to just keep talking forever, but blockchain is the same concept, but it's a bunch of computers linked up together, maybe in a circle or something, right? And there's this encryption step from one to the other. So somebody does this and they post a transaction, they buy some Bitcoin or whatever, and then that gets encrypted and decrypted through like a long chain of computers that are all connected together. The network verifies it through this long, complicated thing. So yeah, quantum computers might cause some threats or issues there, but I know there's already other coins, I think Ethereum and some other ones that are built with this, with protections against quantum computers.
Yeah, I mean
Yeah,
that's
so
like
people
a
are already thinking about it.
right. You hope as a average everyday citizen with an online banking account, it's like, well, I hope my bank invests in this
Yeah,
kind of post quantum cybersecurity measure because I don't have the resources to do that
yeah,
myself.
yeah. Yeah, I'm sure it'll I tend to think everything will be fine. A lot of these like future techie things can get kind of doom and gloom, and it's easy to get freaked out about it.
Right.
But I think in reality, it's probably going to be great. It'll be fine. Yeah.
I like that. Yeah, let's roll with the optimism here. On the sunny side of things, what do you see as some of the developments in technology that are going to be beneficial? What are you most excited to see on the horizon?
Oh, right now, I'm really excited about humanoid robots. I'm kind of a Elon Musk fanboy, and I know he's pretty controversial right now with everything happening in government and whatever, but I've been following him for a long time. Yeah, just everything he's doing, from putting humans on Mars, making life multiplanetary. That's awesome. Electrifying transport. That's awesome. He's got Neuralink helping, doing this brain computer interface thing, which is amazing, and helping people gain the ability to control different parts of their body again. And but the new all of those things are realized technologies now. He's kind of proven that they can do it, and he's sending rockets and landing them on their own, and all. But the next one that's kind of coming is these humanoid robots, and it's interesting timing with AI, right? AI is now the big buzzword. It's getting integrated into every single product we know, and with self-driving and stuff. The Teslas have this huge network of cars all throughout the world that have cameras on them, and they're driving, and they're getting drive time. And with every single one of those hours, they're getting better understanding the world. Actually, AI in general is like a generic way to synthesize and understand any system. It can be anything. It could be the animals. It can be like chemical bonds. It can be kind of anything. AI is just really good at learning things and understanding them. And so now we're at this crux point, I think, with self-driving cars. And I don't know if you have you ridden in a Tesla lately with the self-driving?
No, no, I've
No.
not.
It's pretty awesome. I encourage anyone listening, if they have a friend or whatever, hop in and just go for a ride, and have it just drive them around. And it's pretty amazing what it can do.
Right.
I guess my point is that AI is getting really, really good at understanding the universe, operating in the universe, and now it's gonna start leaving the computers and entering the real world in this visceral, like a physical form of these humanoid robots that can do anything. It can mow your lawn, it could cook breakfast for you. Just name a thing. You know what I mean? Not only could it be a teacher, but it can be like the best teacher in the world to your kids at anything that the kid wants to learn, like smarter than the world's smartest scientists. The weird thing is, like, we're going to have this super large network of robots like interacting in the world. And at first, they're going to kind of suck. Like you're going to be like, hey, can you please like fold that laundry? And it's like, what's laundry? Like it's not going to be very good.
Yeah.
But then pretty quickly, it'll be like the best laundry folder that the world has ever seen. And that's just going to be the case with everything. And so I'm pretty excited about just what that means for society. A lot of people are skeptical and think it's going to be a lot further off than Musk is saying it's going to be. And the weird thing too is the rate of change for AI is another like hyper exponential. So it's kind of hard for us to understand how much better it's getting and how quickly it's
Right.
getting better.
Right. Like the concept of AI didn't even really exist for most of my life, and now it's every month it feels like there's another huge breakthrough, another huge breakthrough. It's getting like so much better and better, and I'm imagining it's like this virtuous cycle where the improvement of it makes the ability to improve it that much better, and like you're saying on this exponential curve, who knows how fast it'll happen and what different use cases can be found out. And then, yeah, if it starts linking up with robotics, if it starts linking up with quantum computers, and then those are all kind of symbiotic and accelerating the progress and
Uh,
each other. Yeah, it's kind of wild. And some folks think it's going to happen. Some folks that thinks it's going to ruin our human experience. Yeah, if the robots can do all of our jobs for us, then what are we left to do? Do you have any thoughts around that? If you were going into college these days or like going into high school or whatnot and could peer into the future and see what would be best place to position yourself given all of these technological tools that are either currently existing or going to be out there really soon, like how would you position yourself to best leverage them?
I think for anyone wondering what kind of career they should do, like they should follow their interests or maybe like the Venn diagram of like the things you want to do, the things you're good at, and the things that'll give you like a decent quality of life. You know what I mean? Like you shouldn't just go after money or you can follow your passions as whatever it is, an artist or a singer or whatever, but it's probably good, a backup plan or whatever. I wouldn't be too afraid of AI taking our jobs or robots taking our jobs. I think as these tools get better, it's just going to help us do more. And that's already the case for me as a programmer. Actually, programming is one of the things that AI is getting really, really good at. And now it's pretty amazing. Even just a few months ago, maybe 6 months ago, I would write every single piece of code myself. And if I wanted write a script, it'd take me a couple days, one day to write it, and then a couple days to kind of work it out. And but now lately, like these past few months, I've found myself when I'm about to write something, just starting with AI and basically describing the thing that I want. Hey, I want this script to do this. It needs to have these parameters. It needs to have, do X, Y, and Z. And then it spits something out that's pretty dang good, and maybe I have to go back and forth with it a little bit and like, no, I actually meant this, or okay, add this or change it. And then finally I go in and actually write maybe a couple lines of code, add or change something. But it's changed my ability as a programmer, shortened that time frame to what I could do in maybe a week. Now I can do it in a day or half a day. And even code in languages that I don't really know. As a programmer, there's a lot of different languages, C and C sharp and HTML and C++ and Java and Python. And once you know one, you can kind of read and understand all of them, but that doesn't make you good at it. So now I have the ability to write code in languages that I don't even know. Like, hey, I want to create an application that does this. Like, what technology should I use? And then it tells you, you should write this in Python. I'm like, okay, can you write that for me in Python? And it's like, yeah, sure, here you go. And then I'm like, how do I run this? How do I use this? And it's like, oh, install this tool and then run this command. And then you're like, oh, this command isn't working. And it's like, oh, it looks like you need to install this library or whatever.
Wild.
Programming, I think, has finally gotten to the this level of you can just speak to a computer and output code. Like it used to be everyone thinks of these low level ones and zeros and stuff. And actually, my mom in university was got a math degree, and her first job was programming. And she used to do everything on paper and like all the math, all the code, and then you punch like a physical punch card, almost like one of those Scantron sheets or something like that. And
Mhm.
then you feed in your punch card into this machine and it tries to run your code and then it prints out this piece of paper with all your mistakes on it and stuff, right?
Yeah.
And so we've gone to that from people. I guess the point I was trying to make with programming is like there's ones and zeros, and then there's kind of a layer on top of that, like hexadecimal. And then on top of that, there's like, well, there's a bunch of layers in between, but then you get C code, which is like really low level programming, and it's like very obtuse and hard to understand, right? So, and then it's gotten more and more and more as I started getting into university. You have object-oriented programming where you're naming your variable, like I have a user name JT, like it's getting more closer to natural human language. And then now with AI,
Mhm.
it's literally you don't even have to type. You can just hit the speaker button and talk to your phone and be like, hey, write me some code that does blah 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 blah, and it just does it. So I
Yeah.
think we're gonna get there with everything. If you're a marketing manager, you'll have a team of AI bots and you'll be like, hey, AI bots, I want to create an ad campaign that does this and this and this. And hey, you start generating images for me and let's look at them together. And you know what I mean? Like, it's just going to amplify our ability to do work and we'll be able to do a lot more, a lot quicker. And so, yeah, advice to young people going into the careers. Because I've even heard some people say, like, oh, I don't know if I should be a programmer anymore because AI can just write all the code for me or
Mhm.
whatever. But I think, at least for our lifetime, humans represent that human will and curiosity is an important piece that can't really be forgotten or left out of the equation. So I think we'll always have a piece of this, yeah, of human will, of having desires, having expected outcomes, like, but we won't necessarily need to be a rocket scientist to build a rocket. You can just say, hey, I want to build a rocket. How do I do that? And intelligence is just going to help you build a way better rocket than a team of scientists could in the past. And so
Wow.
I think
Yeah.
we'll always be there as at the center, like imposing our will on the universe. And now we just have super effective tools to do that for better or worse.
Yeah, yeah, I like the way just frame it. Like it's a very powerful tool. It's not going to replace the human because you still need someone to use the tool to like, wield the powerful extension of our own abilities to get things done. Very cool. Yeah. Well, we're coming up on our timeline here, but wanted to give you the opportunity to leave with any final thoughts for the audience that you wanted to get out there.
It was a lot of fun. Yeah, it was really a lot of fun speaking with you, JT. It's always fun talking about the universe and AI and technology. And yeah, maybe the final thought is just that I think the future is going to be good. I know all this stuff can be scary, but I think it's better to be an optimist about it. Of course, there's going to be negative things that are consequences of these crazy technologies that are changing every day and stuff. You know, if you look back at the past and we're living in the best time in human history, it's better for us than it ever has been for humans. Like we have the most free time, we have the most safety, success, entertainment than it's ever been before. And I think that trend is going to continue. Like, I think as humans and maybe the media, we tend to focus on all this doom and gloom or craziness of it all. But I think if you take a step back and be like, actually, things are pretty great for us right now, and I think they're going to keep getting better. So yeah, it's good to just be optimistic about the future.
Yeah, it's a great perspective. You always got to take the optimistic route, especially when leveraging these very, like you're saying, fast moving technologies. Might as well get the most out of them and find out how to set yourself up for success. So, yeah, thank you again, Kurt, for coming on the show. And yeah, looking forward to having you back on sometime.